Okay, welcome everybody. This video is on section 4.10 in your textbook. It's the last one that we're going to do. Okay, so this has to do with balancing redox reactions. Redox is a fancy way or a fast way of saying oxidation reduction reactions. They put the reduction part first and the oxidation part second just because it sounds better than oxred. So redox is probably a better way to think of that. So balancing redox reactions, this is a little different than balancing normal reactions in that both the number of atoms has to be balanced on each side of each kind, but the charge on each side also has to be balanced. That's what's different about oxidation reduction reactions. So let's say we've got this reaction where solid zinc is dipped into a solution of, say, silver nitrate, and the nitrate is not in this reaction because this would be an example of a net ionic reaction. So I'm going to leave out the spectator ions. So if I was in class, I would show a piece of zinc dipping into silver nitrate, and what would happen is you would see the solid silver appear on the piece of zinc, and then the zinc would be turning into +2 ions. So what I want to be able to do is balance the reaction. Now if you look at the elements, well, I've got one zinc on each side, I got one silver on each side, so it seems like it's balanced. Problem is the charge isn't balanced. The total charge on this left side is 0 plus 1, so that's a +1 charge. The total charge on the right side is +2. 2 plus 0 is +2. So I'm going to balance that charge. Well, how do I do that? I do it with a method called half reactions. It's a little strange, but we're going to break this reaction into two parts, an oxidation half and a reduction half. So let's write the oxidation half first. How do I do that? Well, I have to figure out what's being oxidized. What element is being oxidized? So think about it for a second. Zinc is going from a 0 to a +2. So is that oxidized or reduced? Well, it must be losing electrons to get a +2 charge. So losing electrons is oxidation. So we can say that zinc is oxidized. So here's how we write a half reaction. We simply write zinc on one side and the zinc +2 on the other side. And what does oxidation mean? It means it's losing electrons. So what side of the reaction should I put electrons on? Well, if the zinc is losing electrons, I'm going to put it as a product. So I'm going to write it like this, +2 electrons, because zinc had to lose 2 electrons to get that +2 charge. So that's the half reaction for this overall reaction. The reduction reaction, here I've got silver as a +1 going to 0. So what's happening to it? Well, it's gaining electrons, so that's the reduction part. So I can say that Ag +1 is gaining 1 electron to form solid silver. Okay? So those are known as the half reactions. Now I have to be able to add these up to get an overall reaction. Now the problem here is I've got to balance the number of charges as well. You can see in this half reaction I'm producing 2 electrons, but in this reaction I'm only using up 1 of them. So the way I balance the charge is I multiply this half reaction by 2. That will give me 2 moles of electrons being used up, balancing the 2 moles of electrons that are being produced. So let's add those 2 half reactions together, and then I get zinc +2 silver ions, +2 electrons. Okay, that's everything on the left side. And then everything on the right side is a zinc +2 silver atoms, because that whole half reaction is multiplied by 2. And I've also got those +2 electrons on the right side. So I just added both sides of the reactions. But since I have 2 electrons on this side, 2 electrons on that side, I can get rid of them. And I would call that the balanced oxidation reduction reaction. So notice the elements are balanced. 1 of those, 1 of those, 2 of those, 2 of those. But now the charge is balanced as well. +2 here. Sorry, should be a +1. Okay, so I've got a +2 charge here, 2 +1s, and I've got a +2 charge here. And so the balanced equation includes the number of atoms and the charge. So you're going to balance equations that are oxidation reaction by making half reactions. Okay. So replay the video if it went too fast, just to get it back again. And I have one more example that is a little bit more complicated, and my guess is you probably won't have to do much with this on the AP exam this year, but it's good to be exposed to this idea either for the future or in the off chance that you might have to see something like this on the AP exam. Okay. Okay, so I want to be able to balance this oxidation-reduction reaction. The reason that this is a little more complicated is because this kind of reaction is done in an acid solution. But a lot of the things are still the same. So first step is to figure out what's oxidized and what's reduced. So let's do the easy one first. Iron is going from a +2 to a +3, so it's looking like it is losing an electron. So I can say that iron is oxidized. Okay. Oxidation is loss of electrons. What's reduced here? Well, there's only a couple of things left. Number one, that oxygen here, there's no oxygen on the other side. That's going to be the problem we're going to encounter. The only other element is manganese. So manganese has to be the one that's reduced. So let's see if we can figure out how that is. We know manganese is a +2 charge here. What is the charge on manganese there? A little practice. Well, there are 4 -2 oxygens, so that's a -8, and it's going to have to add up to -1, right? So what's the charge on the manganese there? It's going to have to be a +7. Okay? Does everybody see that? Okay? So if manganese is a +7 on this side and a +2 there, what had to happen to it? Well, it must have gained electrons, so we can say that manganese is reduced. Okay, a little more complicated. So to balance this equation, I'm going to have to do the half reactions. Number one, we can see that each element is balanced, except I don't have any oxygens on the right side. So I'm going to have to balance elements and charges here, because the charges aren't balancing either. I've got a -1 plus a +2, so that's a +1 charge on the left side. And on this side, it looks like I've got a +5. So the charges aren't balanced, the elements aren't balanced. So what do I do? Well, let's write separate half reactions. So let's do the hard one first. Let's do the reduction first. Okay, so manganese is reduced. So I'm going to write the whole thing that has manganese in it. So MnO4 minus, turning into manganese +2. So the first step is to balance the oxygen. We're going to balance the oxygen with waters. Okay, I'm going to try to go a couple colors here to make it easier. Okay, so what do I mean by that? Well, let's rewrite this. MnO4 minus goes to Mn +2, and I got to balance the oxygen with water molecules. I need 4 oxygens, which means I'm going to need 4 water molecules. Okay, now I've introduced hydrogen. Darn, now I got to balance the hydrogens. So I'm going to balance the hydrogens with H+ ions. Remember, I need the solution to be acidic anyway, right? So I'll balance hydrogen with H+ ions. Okay, so let's rewrite that. And I'm going to expand a little bit here. MnO4 minus. And how many hydrogens do I need on the left side? I've got 8 hydrogens here. I need 8 hydrogens here. So I'm going to add 8 hydrogen ions. Okay, and I still have the Mn +2 and the 4 waters. Okay, and now I've got each element is balanced. Looks good, except I don't need just one of them, I need 8 of them. Okay, so I've got 8 hydrogens on each side, 1 manganese on each side, and 4 oxygens on each side. So everything is balanced as far as the elements. The charge isn't balanced yet, we're getting to that. So let's balance the charge with electrons. Okay, so I've got a total charge here of what? Plus 8 minus 1, so that's a total of a plus 7. Here I've got a plus 2, so I've got to balance it with electrons. So I'm going to have 5 negative charges over here, and that would drop the plus 7 to a plus 2, which makes the same as the plus 2 on this side. Okay, so hopefully everybody can see that when you go through the video again. So I'm going to add 5 electrons on this side. Okay. Okay, so that's the reduction half reaction right there, a little bit complicated. The oxidation one is a lot easier. So the oxidation is simply Fe plus 2 going to Fe plus 3. Okay, so again, first step, balance the oxygen with water. Don't have any oxygens. We've already got 1 iron on each side, so that's good. All we got to do is balance the charge. So how do I balance the charge? I'm going to have to add electrons on one side or the other. What side do I put them on? Well, if I only add 1 electron on this side, then the charge here becomes plus 2. Charge there is plus 2, so I balanced that oxidation half reaction right there. Okay, so now I've got 2 balanced half reactions. The reduction half right there, the oxidation half right there. Now I've got to add those 2 half reactions together. The only problem is I've got 5 electrons on the left side here when I add these 2 reactions, and I've only got 1 electron on the right side. So anybody have a guess on what I would do? Of course, Sam's probably got it already. I'm going to have to multiply this entire half reaction by 5. That will multiply the 5 electrons, then that balances the charge. So now I've simply got to add the 2 reactions together. So let's write this reaction with the 5s already. Okay, so I'm going to have 5 Fe plus 2 goes to 5 Fe plus 3 plus 5 electrons. Okay, now we can just add these 2 half reactions together. The 2 half reactions, again, I'm going to use a different color here. So that's the oxidation half reaction, and there was our reduction half reaction after I did all those things to it. Now we're just going to write it all together, add them up, and again, I'm not going to write the electrons because I have 5 electrons on the left side when I add these 2, and I have 5 electrons on the right side when I add these 2. So all I got to do is write everything else. So I'm going to have MnO4 minus plus 8H plus, and then also on the left side are these 5 Fe plus 2s if I'm adding everything on the left sides. Then on the right side I'm going to have an Mn plus 2, and I've got 4 waters, and then I've also got these 5 Fe plus 3s. Okay, and again, I left out the electrons because I've got 5 on the right side, 5 on the left side, they would cancel out. So I would say that this right here is known as the balanced oxidation reduction reaction in an acidic solution. Double check, 1 manganese on each side, 8 hydrogens on each side, 4 oxygens on each side, 5 irons on each side, and then does the charge add up? Well, here I've got 5 plus 2s, which is a plus 10, plus 18, so plus 17, and hopefully I've got plus 17 on this side. I've got 5 plus 3s, which is 15, plus 2 more is a plus 17. So the elements balance and the charges balance. So that's known as an oxidation reaction, reduction reaction that is balanced, again, both for the atoms and for the charge. This is pretty complicated. My guess is you won't have to do it on the AP test, I think I'm going to give you one of those on the homework assignment. And we'll be talking more about homework and what's going to be expected of you in Canvas once we get to our Zoom meetings next week.